Hi, I'm so glad you're here for this video and to review with me some algebra topics that we will need to solve geometry problems in the near future. Now, we worked through a pre-course test together and we worked on the textbook page CC 63, and that's at the beginning of the book. And I pulled out 5 topics that are very helpful for you to be able to work geometry problems if you are good at these topics. So we're going to work through an example of each, and we're going to just work through the problems in the textbook CC63 on these 5 topics. We're going to solve multi-step equations. We're going to solve and graph inequalities, solve proportions, evaluate powers, and simplify radicals. All of these are excellent topics that you worked on in the past, but that you'll need again in the future. Are you ready? Let's go. It's a great example on solving multi-step equations. And this one's got working with negatives a little bit and also a fraction. And in this problem, we're going to solve for d. Ready? All right. So do as you would normally do to start getting all of the things away from the d, and we're going to add 6 to both sides, and we get d over 4 equals negative 9 plus 6. I know that that is a negative 3. Now, what do I do to get that 4 out of the denominator? I'm doing the opposite operation that is there to remove it from this side and get it to the other side. If it's divided by 4 in this case, I'm going to do the opposite of division and multiply both sides by 4. Why do I do that? I do that because I can get the 4's to cancel, and then I've just got negative 3 times 4, and I'm not afraid of fractions because that was pretty easy. Done. Let's try this one. This is an inequality, but it's got a less than or equals to. We're going to do the same process as if that were an equal sign or an equation, and then we'll figure out what to do. There's one thing that we have to really think about when we get to dividing by a negative, and I think you'll remember what to do. Let's just solve this as if it were an equation. I would subtract 3, and I would get negative 4k is less than or equal to 8. Now, this is where that funny rule comes up when you're solving inequalities. And when you divide by a negative, you have to switch the direction of the inequality. Does that make sense? So if I divide both sides by a negative 4 to get rid of that negative 4, then I have 8 divided by negative 4, and I have k is greater than or equal to a negative 2. If you ever divide by a negative, if the operation is a division by a negative, you must switch the direction of the inequality. So let's look at this. K is greater than or equal to a negative 2. I'm just going to put 0, negative 1, negative 2, and then I'm going to say it's greater than, K can be any value that is greater than negative 2, but I'm going to fill in the circle this time because K can also be equal to negative 2, so it's a closed circle. When you have a greater than or equal to, or a less than or equal to, you fill in the circle. Remember that? Good. Don't you just love solving proportions? Maybe not until you remember the really easy step that you have to do. And there's a term for it, and I think some of you guys know it. But what you've got to do when you have to solve for a variable and you have a proportion, you have to, what's that called? When I put the arrows like that, we cross multiply. So let's cross multiply. And we've got 9 times k equals 2 times 6, which is 12. And now we're going to solve for k. And we're going to get k equals 12 over 9. Now we could probably, well we can, simplify this fraction. And that's another thing that you'll have to do. If this answer doesn't show up, but a simpler form of the answer shows up, you'll know how to find it. So let's just reduce this fraction, and I am going to reduce by the highest possible number that I can divide into each of those numbers. And what can I divide into those? The highest number is 3, and we've got 12 divided by 3 is 4, and 9 divided by 3 is 3, and we have just simplified that fraction. Now let's evaluate powers. 9 squared, 9 times 9, 81. 12 cubed, not 12 times 3, 12 cubed, 12 times 12 times 12. 12 times 12 is 144 times 12, and I really don't know what that is off the top of my head. Thank goodness I brought my calculator. Now let's talk about simplifying radicals. We're going to simplify some radicals, and I'm going to do a couple of problems that aren't in the book. And in the future, we're going to work a little bit more on simplifying radicals because there's some great tricks and great process to use. And if you have trouble simplifying radicals, then use this process and practice it, and you'll be great. So let's do this. We've got the square root of 18. Now what I'm going to do is I'm going to make something that you've all done before, but you might not remember. And I'm going to make a factor tree. What I'm going to do is break it down. I always like to say that when you need to simplify radicals, you got to break them down. And you got to break them down into their prime factors. What's that mean? Let's just break it down. What times what is 18? Well, we know 18 times 1, but that's not going to help us too much. 2 times 9, right? And any combination of numbers that works to get you what times what will get you 18. That would work. So we're okay with the 2. So I'm just going to underline the 2 because that's as far as we can go. We can't break down the 2 anymore. It's already as far broken down as it can be. Can we break down the 9? Yes, we can. It's 3 times 3. So now I'm at the end of the line for all of my factor tree, and I've got a 2 and 2 3s. These are the 3 numbers that I'm working with. Now, I like to say if it's under the radical and there's a pair of them, they can come out of the radical as one number. So what do we have a pair of? We've got 1, 2, and 2 3s. So I'm going to circle this pair of 3s because that means they can come right on out of the radical, and anything that's left all by themselves has to stay in the radical. So the 3s came out as a pair, but we only write it once if it came out of the radical. And what's left over in the radical? A 2. And that is how you simplify the square root of 18. Now let's try this. What's the square root of 25? 5. And what's the square root of 4? 2. That's 5 times 2, 10. So if you can get a perfect square, or the square root of 16 is 4, the square root of 4 is 2, the square root of 25 is 5, square root, you can just simplify it right there, and you can multiply. Now, what's the square root of 2? We don't know. It's not a perfect square. And the square root of 6, can we break down the square root of 6? I don't know. 6 is 2 times 3. Do we get a pair of anything that we can pull out of the radical? No. In this situation, all you have to do is multiply what's under the radicals and write it as one radical expression. So I'm going to say the square root of 2 times the square root of 6 is the square. What's 2 times 6? 12. That's the square root of 12. Wow. Now, can I simplify that radical? Let's break it down. 12. We could do 6 times 2. We could. We could do 4 times 3. Let's do 4 times 3. 4 times 3. Now, if you do 6 times 2, you'll come up with the same answer. You won't have any problems. 3 is at the end of the line. Can't break it down anymore. 4 can be broken down into 2 times 2. Uh-oh. I have a pair of prime numbers that can come out of the radical. So those pair of 2's, they can escape the radical, and the 3 has to stay inside because it's there all by itself. So we've got the 2's come out with the square root of what's left over, a 3. And that is how you simplify the square root of 12.